This is Pre-Calculus Part 1, Section 4.2, Trig Functions, the Unit Circle on page 482, Example 5, using quotient and reciprocal identities. Okay, the reciprocal identities are super simple. It's just the reciprocal of whatever you get for sine is going to be your cosecant. Whatever you get for cosine, the reciprocal of that's going to be your secant, etc. So basically you're flipping fractions. What you have to be careful of is the square root. So for example, if sine is 2/5 and cosine is square root of 21 over 5, the cosecant, which is the reciprocal of the sine, would be 1 over the sine, which is 2/5. And then to divide by a fraction, you actually multiply by the reciprocal. So you would be multiplying 1 by 5/2. For cosine, this is where you have to be careful. If you take the reciprocal of the cosine, you have 5 over the square root of 21. Again, you're dividing by a fraction, so you multiply by the reciprocal. But we can't leave square roots in the denominator. So we have to rationalize that by multiplying top and bottom by that square root, because that gives us a square root of 21 squared on the bottom, which is 21. The square root and the square cancel out. And then 5 square root of 21 on the top. For the cotangent, it showed up here finding the tangent, which is just sine over cosine, is one way to find it. So they did 2/5 over the square root of 21/5. Again, you're multiplying by a fraction, dividing by a fraction, so you multiply by the reciprocal. And again, you end up with, the 5's just crossed out here, or reduced. But again, you end up with the square root of 21 in the denominator, so you have to rationalize it, leaving you with 2 square root of 21 over 21. So the cotangent would be the reciprocal of the tangent. You can go through this process, this same process here, by putting cosine over sine, or you can do, instead of having to rationalize the denominator again, notice they didn't take the answer for tangent and put 1 over that. They backed up and put 1 over this, the 2 over the square root of 21, because if once you take, when you divide by that fraction, you take the reciprocal, you're done, because the square root's not in the denominator. So any of these are values of tangent, and it was just easier to take the reciprocal of that one than this one, because we'd have to go back and rationalize again. And you can do the same thing with secant and cosecant if you have square roots in the denominator. So for example, for checkpoint 5, it wants you to find the other 4. So if the sine is 2/3, the reciprocal of that, the easy way is just literally 3/2. The reciprocal of the cosine is going to be your secant. So you're going to do 3 over the square root of 5, but again, you have to rationalize that. So you're going to multiply top and bottom by the square root of 5. That would give you the square root of 25 on the bottom, which is 5, and then 3 times square root of 5 on the top. Tangent, 2/3 over square root of 5 over 3, sine over cosine. So that's 2/3 times the reciprocal of this, 3 over square root of 5. Again, you have to rationalize, because we can't leave that down there. So you get 2 square root of 5 over 5. For cotangent, you're going to do 1 over tangent. But again, instead of doing this and have to rationalize that again, we're going to back up to right here, this answer, the 2 over the square root of 5, because when we flip that over, we get square root of 5 over 2, and we don't have to worry about rationalizing the diameter. Denominator. So just a little trick, that if you're taking the reciprocal of something that has a square root in it, if you can back up to where the square root was already in the denominator and take the reciprocal of that, it saves you having to rationalize again.